is Sriram Natarajan. I'm a program manager. I work on the Microsoft Azure Stack product. I have with me here Sadiq, who is my co-presenter for the day and partner in crime. Together, we're going to talk to you about DevOps and tooling for the hybrid cloud platforms. At the end of the session, there's really one main objective that I want to get you guys in at is I want you guys to understand what does hybrid DevOps mean and how to do hybrid DevOps between Azure and the Azure Stack platforms. We will also talk about what's a quick way to onboard onto these things, do a quick demo, make a quick proof of concept to kind of show the value proposition of Azure and Azure Stack as hybrid development platforms. And because this is a 45-minute session and we're talking about a 300-level concept, I have a few assumptions that I'm going to make. If you don't fit into any one of these assumptions, I request you to take a look at the other sessions that we've been having throughout the week and then taking a look at this session. I'm going to assume that you're familiar with a DevOps concept overall. I'll talk a little bit about it, but I'm not going to go into super depth about it. So I'm hoping you guys are familiar with DevOps to a certain degree. You're familiar with the Azure and Azure Stack value propositions, which you guys seem like you are. And you're somewhat familiar with the services in Azure Stack as well. Again, I'm going to touch on some of these concepts for those of you in the room that are not aware of this, but I'm not going to go super deep. So you can go take a look at the other sessions that we have. We've had quite a few sessions at Ignite. You can use those to get insights into all of these topics. With that, today's agenda. We'll talk a little bit about DevOps on Azure. We'll talk a little bit about DevOps on Azure Stack. We'll talk about how do you build consistent applications. We'll talk about what consistent applications mean, and we'll talk about how to build consistent applications. Then we'll talk about putting it together. We'll talk about hybrid DevOps. We'll talk about what you can do today with the power of Azure Stack and the power of Azure and the Azure DevOps pipeline end-to-end. Of course, there are always some considerations and gaps when you do these things. There are potential pitfalls that you might see yourself fall into. We'll do you one best, and we'll probably talk about those things. We'll talk about where you might actually fall into a potential hole, and we'll talk about how we are addressing them, how we're closing the gaps, and what you can do to not fall into any of those pitfalls. Okay, so what is DevOps? If you put a large object in the room, say an elephant, and you close everybody's eyes, and the person has to describe something by only touching and feeling and like the sense of touch, each person describes it based off of what they can touch and feel. DevOps is the big elephant in the room, to be honest with you guys, right? Those of you who've dealt with different parts of DevOps know DevOps to be that thing. Some of you who've built automation process and tools know DevOps is an automation tool. Some of you, it's a resume line item that says, I can do DevOps. For some of you, it's a collaboration. It's more bringing people together. It's more agile. All of those technologies, all of those release mechanisms that we have. So more faster releases, bringing value faster to customers. So each of you have different perspectives on DevOps. DevOps, quite simply, is a union of people, process, and technology. All three of these things coming together so that you can deliver value faster to your users. All three things, people, process, and technology. Even if any one of these three things falls short, then your DevOps model will fail. Many people who've tried doing DevOps in their enterprises and failed will tell you exactly this. If you don't have the right people with the right mindset, set up the right processes to be able to build, deploy, and monitor your code, and set up the right technology to be able to do those operations, your DevOps pipelines tend to fail. That is quite literally a one-liner about DevOps. When you want to build an application, when you want to release an end-to-end application, you go through 4, probably 5 different phases. You plan and you track, then you code, then you set up, build, and test automation engines like continuous integration, continuous deployment. Once that is done, you release it. You release it periodically. You release it deterministically. You use technologies that will let you do deterministic deployments time and again. And the last bit, this is the most important bit, is once your applications are deployed, you monitor them. You take a look at how they're performing. You take a look at logs. You troubleshoot them as and when things go wrong. And most importantly, you feed them back into the development cycle. And you keep doing this loop on and again so that the product that you're delivering becomes much more robust, and it becomes so much more easier for you to deliver value to your customers. That is why DevOps is important. Now, we talked about those 4 or 5 tasks, right? We talked about planning, coding, building, testing, deployment, and most importantly, running them and monitoring them. Now, in a Microsoft world, if you're a Microsoft shop, Microsoft has all the tools that are necessary for you to be able to complete your DevOps pipeline end-to-end. We used to have VSTS, now it's called Azure DevOps, and it's split into 4 unique offerings for you guys to make it simpler. But with the help of Azure boards or Azure repos, you're able to now plan, track, and code. With the help of Visual Studio Code, you're able to check in code. With the help of the Azure pipelines, you can build, you can set up continuous integration, you can set up continuous deployment. With the help of Azure services that we have, like Key Vault, you're able to operate your services securely. And again, more importantly, you're able to monitor, regardless of what your application might be. It might be a simple web app, it might be a virtual machine. You're able to use tools such as Azure Security Center, Azure Monitor, Azure Application Insights to be able to get continuous insights into your application's performance, and you're able to feed all of that back into your planning, right? This is the DevOps cycle I was talking about earlier. Now, if you're not a Microsoft shop, if you've already made investments in other technologies, open source technologies, that is still applicable. You can still do technologies in a completely open source world. Who would have thought? No? Okay. You can totally use things like Trello, GitHub, Jenkins, Terraform, Ansible, Elk Stack to be able to do the exact same things on an open source world. The great thing about the Microsoft DevOps pipeline, the Azure DevOps pipeline is, if you've already made investments in open source technologies, in some open source technologies but not everything else, we're building our DevOps frameworks to be flexible enough for you to be able to plug in your choices. Like instead of the Azure CI/CD pipeline, you could totally plug in Jenkins. Instead of using VSTS or the Azure DevOps to store your source code and do version control, you can totally use GitHub, right? We are building our pipelines in a way where this becomes very flexible for you to make the decisions you want that fits your business. Again, it's the right combination of people, process, and technology. We've defined the process. We're trying to get the people going. We're enabling you to get the people going. And we're enabling a technology stack that will let you do this comfortably. Let's talk about hybrid. Talked about DevOps, we've talked about releasing it. A lot of you are foraying into the concept of hybrid now, where you're seeing that your on-premises deployment, you want to be able to deploy your applications in more than one cloud location, so to speak. You want your applications to start spanning multiple locations, multiple clouds, for resiliency, high availability, for sheer functionality, what have you. So we've started talking about this concept called hybrid DevOps, or building a hybrid pipeline. Pretty much everything that I showed you in the previous slide is the same, except your deployment target can either be the Azure cloud or the Azure Stack cloud. That is our biggest value proposition with Azure and Azure Stack in the Azure ecosystem. Because Azure and Azure Stack are consistent cloud application platforms, your applications can go through the exact same pipeline, go through the exact same process and technology, and can be completely agnostic to which cloud platform they can be deployed under. You can point them to Azure, the app should work. If you point them to Azure Stack, the exact same applications will be deployed as well. Now, before I go into hybrid DevOps and talk about DevOps in general, I'm going to talk to you about consistent application development, because this is very key. Not a lot of our competitors can talk about this with as much robustness as we do. We talk about application development, and because Azure and Azure Stack are consistent app platforms, you can have consistent applications. You can build the apps the same way for Azure or Azure Stack. You can use common DevOps practices and use the same tools to deploy against public Azure, Azure Government, Azure China, Azure Germany, as well as the Azure Stack Cloud platforms, the same applications. So let's quickly jump into a demo. This session's going to be a little demo heavy. Let's jump into a quick demo about how you can build an application and how you can deploy it to Azure or Azure Stack directly from Visual Studio. We're not talking about DevOps just yet. This is just a developer experience. And with that, I'm going to hand you off to Sadiq.
So Shri just mentioned that how do we essentially be able to use Visual Studio to deploy to Azure and Azure Stack? So let's just say I have a simple application, and in my application, I wanted to deploy it to Azure, and I wanted to see if I use the same exact application, can I deploy it to Azure Stack? Is there something I need to change? Do I need to rewrite the entire code? And the answer really is no, you don't. For my application, as long as I logged into Visual Studio correctly, you can go to deploy, and once you go to deploy, I'm going to start with deploying it to Azure Stack because I'm going to use Azure Stack as my test environment or a pre-production environment just to make sure everything is working correctly. So as you can see, when I go to subscription, there are two management there are two ARM endpoints that you can use. One of them is for Azure, and as you can see, the other one is for my Azure Stack portal. That's as simple as it gets in order to just change based on your ARM endpoint to release to release an application. So what I'll do here is I'll deploy it to Azure Stack to make sure it works. And so filling in my parameters, I'll just click deploy. It'll kick off the deployment, and once it'll start to launch. We can check the Azure Stack portal to ensure that that everything went successfully.
So Sadiq, let me ask you a quick question here. So Visual Studio was able to directly detect my both Azure endpoints, my Azure subscriptions, as well as my Azure Stack environment and my Azure Stack subscriptions here?
Yes, it was. And it's able to do that really just by having that ARM endpoint in, as well as your credentials. When we go to our Azure Stack portal, when you look here, we see that the application that I created went through successfully. Now we can do the same thing. We saw that it went through successfully in our test environment. Why don't we see if it works also in our Azure environment? So we can go through and just using the same exact source code for our application, we can just deploy it to Azure now. So we go and we click on our Azure endpoints. I already had it added. And as long as the subscription loads, while we wait for that, we'll be able to deploy it to Azure and see that it's there as well. So like I said, everything already loaded in, subscription, resource group-wise. I click deploy. It'll kick off the deployment again. I saw that it was available in my Azure Stack portal. Now I can go to my Azure portal and see that the same exact application exists as well. And this is how, just one use of Visual Studio that we're able to deploy an application to both Azure and Azure Stack.
Perfect. Thank you, Sadiq. So if you're a developer, this is an appealing experience to you because you're able to build the code in the editor that you're comfortable with, and you can deploy the exact same application directly from the editor into multiple cloud platforms. If you're an IT pro, if you're a solutions enabler, this is what your developers are looking to do. By using Azure and Azure Stack, by embracing the hybrid cloud platform for Azure, this is what you're enabling your developers to do, to be able to build those applications and deploy them seamlessly across multiple cloud platforms. When we talk about consistent application development, it is really made of two things. It's made of services consistency and tooling consistency. What do I mean by that? This is a little bit semantics, but what do I mean by this? If I have to build an application that can be deployed to multiple places, both of those places should have the exact same set of services, the right set of versions that that service needs or that application needs. As well as I need to have the right tooling support so that that tool can deploy to multiple cloud platforms. So when I say consistent application development, I'm really talking about both service consistency as well as tooling consistency. Let's go into detail and take a look at service consistency. We said Azure and Azure Stack are consistent cloud platforms. One of the things that enables this consistency, one of these things that enable the consistent application model is the Azure Resource Manager. The Azure Resource Manager is the universal API for Azure that abstracts all the underlying services from users and gives you a reliable, consistent way to deploy both applications and the infrastructure needed for your applications. ARM supports infrastructure as a code. So for those of you who are familiar with Azure, you're probably writing ARM templates. In the DevOps terminologies, it's what we call infrastructure as code. Being able to define the infrastructure needed for your applications as a JSON file or any format, so to speak, so you can deploy that infrastructure over and over again deterministically and know that that's the exact same infrastructure that you get every time you deploy. This is one of the biggest concepts of DevOps, and Azure Resource Manager enables that for you in the Azure ecosystem. And then again, if you build a tool for ARM, you can be sure that that tool will work regardless of whether you're pointing it to the Azure cloud or the Azure Stack cloud. So the Azure Resource Manager is one of the biggest tools, one of the biggest weapons we've got in our arsenal to be able to enable hybrid DevOps across clouds. Then again, this is the bit I'm not going to go into very detail about. We've got two clouds, the Azure Stack, and we've got some subset of services that we have in Azure shipping on Azure Stack. So on Azure Stack, we've made our efforts into shipping those basic services that is needed to get out the door for you guys, which is compute, network, storage. If you're building web applications, we've got web apps and PaaS. We've got a SQL, MySQL adapter, and we've got Key Vault for security, as well as we have a long ecosystem of ISVs that contribute to our marketplace. In addition to this, our primary mission is that we will keep bringing more and more of these Azure services down on premises. So the services consistency piece of our promise is guaranteed for you guys. Here are some of the ISVs that we have in the Azure Stack marketplace. This is a very limited list. We've got about 200 or so items that you can syndicate directly from Azure. That's key here. You can take those items that are available to you in Azure, download them to Azure Stack, so you as a developer or your developers can be confident that the exact same platform that they're building their applications on looks exactly the same way, both in Azure as well as Azure Stack. One of the biggest examples that I give people these days is we're working on Kubernetes. We're working on an AKS-based, an AKS engine, ACS engine-based Kubernetes template on Azure Stack. It's actually announced to be in public preview as of this Ignite. When you deploy that template and when you deploy the Kubernetes template in Azure, the networking, pretty much all the resources that get spun up are exactly the same, if not similar. OpenShift is a great example too. When we've been working with Red Hat to deploy OpenShift, the networking and the configuration and just the sheer platform, the look of the platform is the exact same as it is in Azure for you guys. So your developers, or you as a developer, you don't have to learn different things. You don't have to learn, oh, I'm in this cloud, so the configuration just looks here, the networking is like this, so it's going to be a little bit different. Oh, I'm in the Azure Stack platform, it's going to look a different way. No, none of that. You can be assured that the platforms that you're building on look and feel the exact same way for both you and your applications across the Azure Stack platform. That was services consistency. Now let's talk a little bit about tooling consistency. It's not enough to have just the exact same services if the tooling doesn't support multiple cloud platforms. So a second part of our DevOps journey is to enable all the tools that people love and use to deploy resources against Azure to also work across the Azure Stack platform. And we start from the very basic thing, right? We start from the code editor. So they just showed you how, as a developer, I can use my code editor, and my code editor is aware of the cloud environments that I have access to. We start from right there. We build it on to going through the Azure PowerShell, the Azure CLI, tools that you use to deploy your applications to Azure, all the SDKs that we use to build applications. And generally, when I talk about this, people tend to ask me for a clarification. When I deploy an application, I do two things. I deploy the infrastructure needed for my application. in most cases, for dev and test environments. In the production, the infrastructure might already be created, and then I deploy my application. So there's both things that happen depending on your DevOps practice. With the help of Visual Studio, with the help of Azure CLI, Azure PowerShell, and all the SDKs, you're able to embrace that. Storage Explorer is another tool that you use to look at storage accounts in Azure. This tool can, again, natively be aware of both your Azure as well as your Azure Stack storage accounts. So you should be able to manage all of your assets directly from Storage Explorer. Sadiq is going to show you that a little later on. Last but not least, log analytics, application insights. And again, as of this Ignite, if you'd gone to the Azure Stack keynote, we'd also shown how you can use ASR also. Like services in Azure are also aware of not just your Azure resources, but also your Azure Stack resources. And you will be able to use tools like log analytics and application insights to monitor your applications. So to exhibit tooling consistency, I'd like Sadiq to come back and show us Storage Explorer. While he gets that set up, what we're doing up until now is we're talking about all the building blocks that are needed for you to start building a hybrid DevOps pipeline. We talked about coding. We're now talking about tools that you can use to deploy, and we'll go into hybrid DevOps next.
Yeah, so like Sri mentioned, Storage Explorer is just one of the tools that we can use to plan against our hybrid DevOps. There is PowerShell, CLI, and some of the Azure SDKs. What I'm going to show is really just Storage Explorer, and one of the many ways that this helps enable you as well. If you remember in my last application, I deployed, part of my application was deploy a storage account. Essentially, what I've done here is I have my Azure Stack environment on Storage Explorer, and I have my Azure environment. But how was I able to do this? Essentially, what you do is you click to add a new account. When you add that account, you're going to see that under Azure environment, you can use a custom environment. When you try to enable this part and you click next, you'll see already that my Azure Stack environment has been added. Now I can go ahead and delete this, but this was all enabled just by using the ARM endpoint that my Azure Stack has. And I can do this the same way for Azure Stack as I can do it for public Azure as well. That's how I was able to enable both of these cloud environments here.
So Sadiq, let me pause you here for a second. When you added a cloud environment, all I saw you do was pick another cloud environment and just give the ARM endpoint. But we're talking to storage accounts and all of the accounts in storage here. So you don't need any other environments to be able to talk to any of these resources, right?
No. So essentially what happens is once you use that ARM endpoint and you connect to your account, it'll load in all of your subscriptions, which you see here. It has my Azure Stack subscription, and it has my Azure subscriptions that are available. Then it goes down a little bit further, and delving in a little bit further, I'm able to see my Azure Stack subscription, which is the one here, and it has the storage account that I used to create that application that I previously demoed, as well as the storage account that I used in my application to deploy when I deployed to my production environment in Azure. And both of those are located here. This is just one of the many ways that we enable ourselves and you to develop both against Azure and Azure Stack.
Very cool. Thank you, sir. All right. Now we're going to put it all together. Let's talk about hybrid DevOps. This is what we're going to build right now. I'm going to walk you through this, and Sadiq is going to show you how this is being built. The key takeaway from the last demo was that for any cloud environment that you need to talk to, you should be able to discover pretty much everything about the environment by just knowing the ARM endpoint, which is why I said ARM is our key enabler into this entire hybrid DevOps experience. This is a sample architecture for building a hybrid DevOps pipeline with Azure and Azure Stack. As you can see, it involves 3 distinct components, and I'll walk you through each of these things in detail. First thing, developers are key to this operation. Developers using any IDE of their choice, they're able to check in code into the Azure repositories, into Azure DevOps. That could be a Git repository or any other kind of repository that sits in the Azure repos. I have two separate projects in here. I have one for my infrastructure, as I talked about. In this case, it's a web application. So I have a template that deploys a web app, sets up the right set of storage accounts, pretty much everything I need to run that web application. And I have my actual application code, the source of the application that I have. This is one part of the process. Second, I've set up Azure DevOps to have continuous integration and continuous deployment. So every time a developer checks in code, you can set this to be on every check-in, you can set this to be on batching, but every time code is checked in, you can set Azure DevOps, the pipelines, to be able to integrate that code, run BVTs, be able to test it against dev and test environments, and actually set it up for release both in your pre-production and in your production environments. Third thing that happens is Azure DevOps pushes us out to a particular environment. The key thing to note here is, if I go back a little bit, I have these two new concepts called hosted build agent and hosted release agent. The way Visual Studio Team Services or Azure DevOps works is through agents. You have agents that are listening in into your repositories, and they are the ones doing the heavy lifting. They are the ones building your code. They're the ones deploying your code. To deploy code to Azure, because it's accessible from anywhere, I can simply just use the built-in hosted build and release agents to be able to deploy it to Azure, right? So my hosted release agent is now able to take the infrastructure template, is now able to take the application. It's deploying the infrastructure through ARM. It's talking to app services in the backend. It's spun up a website, and it can then put that application that I just built directly into the app services web app that just got created. Now, for my Azure Stack, as you can see, a net new concept comes up called on-premises release agent. Because most of our Azure Stack instances, most of our use cases, regardless of the vertical that we're doing it, you might be in a healthcare vertical, you might be in a financial vertical, you might be in defense, right? Your primary reason for going through Azure Stack may be that it is not connected to the internet, or it has very limited or intermittent internet connectivity. Also, it is inside your data centers, behind a firewall that you don't want people reaching into. So in order to be able to deploy those applications into your Azure Stack, you're able to download a release agent. You're able to download an agent from the Azure DevOps portal, run it locally, and connect it to your Azure DevOps. So now this agent will keep pinging Azure DevOps or team services, and will be able to get the job that's assigned to it, and then be able to talk to your Azure Stack environment. So the agent needs to be running in an area where it can actually hit both the team services as well as the Azure DevOps, as well as your Azure Stack instance. Now, I talked about Visual Studio Azure DevOps as the cloud-based entity, but the Team Foundation server also has a similar functionality. And so if you want to completely do a disconnected install of all of your applications, you can totally use Team Foundation server for this process as well. So CI/CD pipeline, I've started integrating my application. I can deploy it to Azure. I can deploy it to Azure Stack. And the last bit is monitoring. In this particular example, unfortunately, we don't get to show this to you, but because it's a web app, I can totally use Azure Application Insights to be able to monitor this application. If, again, going back to what we did in Natalia's session for the keynote, you will be able, if it's a virtual machine-based application, you should still be able to use log analytics and such to be able to monitor the strength, monitor the patch status or security status of those virtual machines. And we've got a whole array of tools with Azure Security Center to be able to manage both your on-premises as well as Azure assets. But monitoring is a very key part of a DevOps cycle, so that you're able to feed that back into the plan and release process like I talked to you about earlier. I think I've done enough talking. Let's see how this works. Take it away, Sadiq.
Yep. So as you guys will see here, I have a website that is on. I have a website that is on my that is located on Azure, and then I have the same exact website that is replicated on Azure Stack. As you can see, the endpoints are a little bit different. That's how you can tell the difference between Azure and Azure Stack. But how did I get there? How was I able to deploy this web application to both Azure and Azure Stack? Well, first of all, it kind of goes back to what Sri was saying about Azure DevOps and using the CI/CD pipeline to have a build and a release agent that allows for this change. but instead I'm going to show you and I'm going to walk you through this entire process of how it happened. So let's say I want to do a feature change set to this web application, and instead of saying hello Ignite 2018, I wanted to go to my source code and changed it to just say welcome Ignite 2018. This could just be for any website, just changing a simple title.
You're checking in a feature.
Yep.
Okay.
Because this is connected to a Git repository, I'm able to go to Team Explorer. I made my change. I used it to welcome Ignite 2018. I go to Team Explorer and I check in my changes locally. So I'm going to just put this as welcome Ignite, and I'm going to commit my changes. Once it commits those changes, it's committing those locally. I'm going to go and push it up to the server. So once I push that to the server, you'll see it appears. You click on it, you click push, and my build, because I have continuous integration set up on my Azure DevOps, once this goes and pushes it successfully, we'll be able to see that the build agent will have started. So let's go to our Azure DevOps. We go to build, refresh the page. And once it refreshes, you'll see that the build right here, welcome Ignite, starts to kick off. What that essentially starts to do is it starts to get your web application together. If you have NuGet packages, it starts to renew it. You'll see that here, for my simple web application that I have, there's not as many tasks that are associated with it. It starts to initialize the agent, initializes the job, and it starts going through the build process essentially. While this is building, I wanted to show you what happens step by step a little bit through the release, as well as how did we even get it to, how would I get it to push to both Azure and Azure Stack. So once we go to releases, we'll see that here are all of my releases that happens once the build is successful. And to dive a little step further, what is associated with this release? Now, with this release, you'll see I have my build web application, which it's in process of doing right now. And I have two environments that are set up, both my Azure Stack and my Azure environment. Once the build completes successfully, it pushes to Azure Stack, which I'm using right now as a pre-production environment, and Azure, which is my production environment. However, because we have this hybrid cloud application model and because of hybrid DevOps, you can swap this. Instead, I can have Azure to be my pre-production environment, and I can use Azure Stack as my production environment, and vice versa. It really works the same way both times.
So I can dev test in Azure and deploy to Stack and switch them out if I have to?
Yes, you can. So how did we even get to change this? How do we even get to add these cloud environments? So one way we do that is through, again, our Azure Resource Manager service endpoints. Now, when I click New Service Connection, I click on Azure Resource Manager, and we'll see here that there's an environment. You have to enter in your subscriptions. And you see once I click on Azure Stack, it gives me an environment URL. This is where you'll go and you'll put in your ARM endpoint. Once you put in your ARM endpoint and you click OK, it'll go through the process and you fill in your credentials. It'll be able to add that cloud environment to your release agent. And I can just show you a quick example here. So this is what I did for my environment to add the Azure Stack. And as you can see, I have Azure Stack, I have my ARM endpoint and my credentials listed, and I was able to successfully go ahead and install the cloud environment on Azure DevOps. I did the same exact thing for Azure as well. This is my Azure subscription. I go in, I put in my subscription and all of my credentials, and it works the same exact way.
So you don't have to give the ARM endpoints for Azure because it's all commonly known. It's a single tenanted instance, but for an Azure Stack, we might have multiple instances of these things.
Yes, and the Azure Stack endpoint is unique. So that's one of the reasons why you'd go ahead and you stipulate your Azure Stack endpoint in doing this. So let's see if the build is complete. And as you can tell, the build did successfully go through. When you look at all of it, it all succeeded and went through pretty well. So let's check our release pipeline to see if it kicked off as well. So we click on release, well, as I refresh the page, we'll click on release and we'll see that the release has just started. It literally just started, I guess, a couple seconds ago. So if we go into the release, very similar to how I did before, we'll see that both Azure and Azure Stack are in progress of completing their release pipeline with continuous delivery. As it completes the task, these will both refresh the web pages that I showed you earlier. So it will use my Azure Stack as my test environment, and it'll refresh that page, and it'll be able to use Azure as my production environment, and it'll refresh that page as well with the newly updated title.
So right now it's deploying to both Azure and Azure Stack simultaneously. We can also set this to go after one or the other. You can set it to stay, once this environment successfully deploys and all the tests are run, then take it and deploy it to the other environment and subsequently do it. What Siddiq is showing you here is you can have multiple pre-prod environments should you decide that is how you want to go to. Like if you're doing a user acceptance or you're doing some kind of pre-production testing or you're doing it on multiple regions of Azure Stack, you can simultaneously send the builds to multiple environments as well. Once you validated them, then you can sequence your other environments, fully automatable across all cloud environments.
Yep, and so we saw that the Azure website succeeded. So let's just see if it worked. So we've refreshed the page, and as it loads, it should say, welcome Ignite 2018, just waiting for it to give it a couple more seconds to load through. But while that's happening and it starts to work on the Azure environment, the same process is still happening in the background for the release agent for my Azure Stack web page as well. So it is something that you can deploy. And as you can see, the web page loaded, and it says Welcome Ignite 2018 for Azure. Just double checking that this went through successfully for Azure Stack, which it should, and I'll be able to load the same exact thing. As you can see, I can click into it. It would have done the same thing for Azure Stack. I reload the web page, and it'll also say, Welcome Ignite 2018.
Perfect. Thank you, Siddiq. This, to me, is a very powerful demo. I'm now able to take disparate components of our cloud ecosystem, and we're able to put them all together to do something meaningful. To optimize for time, we checked in something very simple, but think about the power of this when you have to check in or when you have to build a net new feature, when you have to build a net new complicated part of your applications in your portfolio. And it is just as simple as being able to check in code and setting everything up beforehand deterministically so that you're able to catch any issues at any stage of the process, and you're able to automate the entire release pipeline end to end. That is the power of Azure, Azure Stack, and the Azure DevOps. So that was the sunny side of the land. Now let's talk a little bit about some of the rainy parts of this thing. Because when you generally tend to do this, there are some pitfalls that you can fall into, because the fundamental nature of running a cloud inside your data center and comparing it to something that we as Microsoft run and get to update on a day-by-day basis. In fact, the previous team I used to be in, the Azure portal team, we used to check in code every half a day, pretty much every day for that matter, right? So there are some operational differences that exist between the Azure cloud and the cloud that you're running in your platform. And as developers, you need to keep that in mind when you're developing applications. This is one of my favorite quotes. Basically, as a journey of 1,000 miles begins with one step. Azure Stack, our foray into Azure Stack and everything that we've been doing in Azure and Azure Stack is our beginning to give you that seamless experience, that seamless application development, hybrid DevOps experience for you, your developers, and your applications across Azure and Azure Stack cloud platform. So that's where we're getting started, and we have a long way to go. To put this back into the frame of this presentation, I talked about how consistent application development heavily relies on service consistency and tooling consistency, right? The same way, the considerations that you have to keep in mind also depend on those services and that tooling that is available to you. And we'll talk a little bit about that in detail. Let's talk about services first. As I said, Azure Stack services will lag behind their Azure counterparts. This is because we check in code into Azure every day. Once the code is mature enough, once we've tested this on our global Azure audience, we then take that code, we package it. Sometimes we even have to shrink it a little bit so that it can fit into your on-premises data centers, and then we ship it on Azure Stack. So by just that definition of the engineering process, the services that are available in Azure Stack will lag behind their Azure counterparts. That's just how it works. We take the innovation in Azure, we bring it down to Azure Stack. What that also means is that the API versions will be a little bit different between Azure and Azure Stack clouds, because again, by the time we bought that to Azure Stack, Azure moves at a much rapid pace, so there might be API version differences. And this is one of the key considerations that a lot of developers need to keep in mind when you're building for the application platform, and when we say consistency. When we talk about consistency, for a particular API version that we have in Azure, and that exact same API version available in Azure Stack, your applications can be completely consistent. If you're taking a dependency on a service in Azure that is not available in Azure Stack, obviously, you're not going to be able to have consistent applications. Or even if you're doing it at a later API version with a new shiny feature that you've taken a dependency on, bringing it back to Azure Stack will not work because the cloud does not yet support that particular feature. Now, my jobs, why we get paid for, is to be able to close that version as quickly as possible. And we're making every possible engineering investment to be able to close those gaps as quickly as possible. And it's a process, and as you know, we're doing it as we speak. In addition to that, we're also enabling you to have consistent programming models. So while we do our parts of the land, you are still unblocked. You're still able to build applications such that you can fold into a common norm and say, okay, if this application is built in a certain way, it can be deployed across hybrid cloud platforms today. That is what we are doing to enable you guys to do that. One of the biggest things we do that, how we do that is through API profiles. Let's take a quick operational example before I hand it off to Siddiq for this, right? In Azure, let's say you have an application that just took a dependency on, let's say, compute, network, storage, Key Vault, and app services. That's 4 services that you have to have API versions for, right? Now you have Azure Stack environments, and Azure Stack will support up to 3 months ago. So you might have different Azure Stacks and different API versions too. So if I have to have an Azure cloud, government cloud, and 2 or 3 Azure Stack environments, I have to know the API versions on all of these services across all of these environments for me to confidently say that this application will work across all of these environments. That is a complicated task. I don't know about you guys, but I suck at remembering numbers. Seriously, beyond belief. What we've done is to make sure that we create these containers, these aggregates, and we've thrown in a bunch of API versions in them. These containers are what we call API profile. An API profile is a hash table, so to speak, of namespace to an API version across all namespaces available to us in Azure and Azure Stack. So instead of remembering 30 or so API versions, if you build your application to one profile, and as long as that profile is supported by all the clouds that you're trying to deploy to, your application will work. That is what we're doing to enable you to address the differences between these services. And Siddiq will show you a little bit about how this is done. We're releasing up to about 4 profiles a year, 3 profiles a year, depending on how we want to do it. We're still working towards how much is too much. Right now, we've got like about 2 or 3, so you can totally do this. The way we're doing this is we've got a latest profile. For those of you who are building applications only on Azure, you don't worry about other Azure Stack instances or even other Azure clouds for that matter, and you want to be on the latest and greatest API versions available in Azure, you build your applications to take a dependency on the latest profile. As time progresses, we keep minting instances in time as a profile, which basically means on this date, we've taken certain APIs and said this is how it's going to look like. And if you take a dependency on that, then that, as long as that application, as long as that API profile, as long as that month, year, and date is supported by that cloud, your application will work. There is still a little bit of optimal stability versus cutting edge that you can make use of here. But if you're going all in and saying, I'm going to build a hybrid application, I know for a fact that this is going to be a hybrid application, You can take a dependency on any of the Dash hybrid profiles, and we will release those in a way that it's supported by all Azure clouds and Azure Stack as well. So first one, latest and greatest, cutting edge. Second is you making your own judgment call on how you want your application to be. Third is us deterministically saying that when you build it to this profile, it is guaranteed to work across Azure and Azure Stack. And if it doesn't, then we're not doing our jobs right. I will give you Siddiq's cell phone number. These are the ones that we have available right now. We've got the latest. We've got a 2017-03-09 profile, and we just recently released a 2018-03-01 hybrid profile. Take it away, my friend.
Okay, so really quickly, what Sri was talking about was API profiles. Everything that I've done today, from my web application, from my application in the beginning, with my storage account to my web application, anything that I've used has been with API profiles. To incorporate API profiles a little bit more, what we've went ahead and done is to target it in all of the SDKs. So Ruby, Java, Python, Java, .NET, and even the Go SDK all has API profiles enabled. So what you do is essentially is, as you see here, we have the profile itself set up. One of the profiles Sri talked about earlier was 2017-03-09. There is a newer profile called 2018-03-01. What this allows you to do is you don't have to stipulate API versions in any of your code. If we were to go through this hybrid compute, which is available online, this is all well documented as well, you'll see that no API version is ever filled out as one of the parameters. When you run this, it'll automatically put in those API versions that were stipulated in that profile. As we continue to have more profiles, it'll have more updated API versions that will work against Azure Stack and Azure as well.
So we've built in the intelligence in the engines to be able to support different versions of API.
Yes, exactly.
Perfect.
So I'll let Sri.
Yep, we're running a little bit short of time, so I'm going to steam right on ahead. We have just 2 more slides left. I apologize for that. Talked about service considerations. Let's talk about tooling considerations. Tools, again, if you are building a tool, if you know somebody who is building a tool, one of the biggest pitfalls that they tend to fall into is hard coding endpoints. Because Azure and other Azure clouds have very well-known endpoints. People just tend to say variable equal to http.management.azure.com, build, compile, ship it, and then they have to be like, oh, I need to support another cloud. Oh, okay, fine. So no hard-coded endpoints. If you can make that configurable, just like how you saw with Visual Studio, just like how you saw with Storage Explorer, all of those gave you an opportunity to enter custom ARM endpoints, because that is important to be able to support Azure Stack environments. Second thing, AED versus ADFS. Same, just like the first one, people generally tend to think, oh, AED is the only way that you can authenticate to an Azure cloud. No, for Azure Stack, you can do ADFS as well. So the authentication endpoint and the way you authenticate is also something the tool needs to keep in mind. Third thing, no strict coupling of API versions. We had to do quite a bit of work in this area. When we first released Azure PowerShell, the versions were deterministic. When you install a certain version of Azure PowerShell, they only took a dependency on a certain API version, which is why we came up with the profiles concept. Now they do. But the point is, when you install a certain version of Azure PowerShell back then, it goes to a certain API version, right? So you won't be able to deploy across multiple clouds because that API version may not be supported by that cloud that you're trying to deploy to. So adhere to profiles and don't hard code your API versions. Those are 3 things to keep in mind when you're building tools and tooling platforms. For more information, go to aka.ms consistency. Also, if you'd been to any of the earlier sessions at Build Today, and if you haven't been to this one, I strongly recommend you go take a look at the recording, was one by Ricardo Mendes and Anjay Ajoda on hybrid application patterns between Azure and Azure Stack. They go into super detail about how you build hybrid architectures between Azure and Azure Stack, and what are the kinds of applications you can build with the power of the Azure and Azure Stack platforms. Tools available today, Azure Service Fabric. We just GA'd it at this conference. So if you're taking a dependency on Azure Service Fabric, a template is available to you today in your marketplace for syndication. We announced public preview of Kubernetes, the AKS-based template available on Azure and Azure Stack. We also announced the release of our partnership with Red Hat to release OpenShift, which is now supported in production on Azure Stack and is available to you in Azure. And we're working with Ansible and Terraform to also be able to support their platforms as well. So consistent app development, services, tooling, and with that, you will be able to build hybrid DevOps pipeline. And with that, we're done. Thank you for staying a little bit over, you guys. Please do give us feedback and let us know what you think.